Welcome to the Q&A session 3 from the playlist of atoms. The topic is the calculation of distance of closest approach in the Geiger Marsden experiment. So we have already studied about this experiment in the previous session. So this session is in continuation of the session number 2. The question here is, in a Geiger Marsden experiment, we have to find the distance of closest approach of the alpha particle of 5 mega electron volt energy to the nucleus of Z is equal to 79. So here Z is the atomic number and Z is equal to 79 is the atomic number of gold. So I am drawing here one nucleus of the gold atom. So since the atomic number is equal to 79, so the number of protons here, so this nucleus will have neutrons and the protons, so the number of protons here will be equal to 79 and the total charge on this nucleus will be equal to 79 into E, where E is equal to 1.6 into 10 to the power minus 19 coulomb. Now this nucleus is positively charged, and as per this question here, the alpha particle is approaching this nucleus of gold atom. So let us say this is an alpha particle. So it is approaching this nucleus. So at the point of closest approach, let us say this is the point of closest approach, let us say A. So at the point of closest approach, this alpha particle will rebound and it will move in the backward direction, because alpha particle is also a positively charged particle. Alpha particle is a helium nucleus which consists of 2 protons and 2 neutrons. So the charge on the alpha particle is equal to 2e. So since alpha particle is positively charged, this nucleus of the gold atom is also positively charged. So at the point of closest approach, the alpha particle will rebound and it will start moving in the backward direction because of the repulsive force between this nucleus and the alpha particle. Now at the point of the closest approach, or you can say when this alpha particle will rebound, then at that point, or you can say at the point of closest approach, its kinetic energy will become equal to 0. So in this question, I will be using the work energy theorem, that is the change in the kinetic energy is equal to work done. Now the change in the kinetic energy will be equal to 5 mega electron volt, because the kinetic energy at the point of closest approach is equal to 0. So 5 mega electron volt, this is equal to 5 into 10 to the power 6 into E into V, and this will be equal to the work done. And work done, as we know that the electric potential is equal to W upon Q, where W is the work done and Q is the magnitude of the charge, and here V is the electric potential. So here in this case, the work done will be equal to V into Q, where V is the electric potential due to this nucleus, and Q is the magnitude of the charge on the alpha particle, and V is the electric potential at the point of closest approach due to this nucleus of the gold atom. So if I multiply this, I will be getting the value as 1 by 4 pi epsilon naught into the charge on the nucleus is equal to 79e divided by R naught, where R naught is the distance of closest approach, multiplied by the charge on the alpha particle, which is equal to 2e. So simply I have to equate the values on the left side and the right side of this equation, and by doing so we will be able to find the value of R naught, which is the distance of the closest approach. So R naught will be here equal to 79 into 2, which is equal to 158 E square divided by 4 pi epsilon naught, and this 5 into 10 into E, this will come in the denominator, and from here the value of R naught will be equal to 158 into 1.6 into 10 to the power minus 19 divided by, now 1 upon 4 pi epsilon naught is equal to okay, this is 4 pi epsilon naught into 5 into 10 to the power 6. Now 4 pi epsilon naught is equal to 9 into 1 upon 4 pi epsilon naught is equal to 9 into 10 to the power 9 into 158 into 1.6 into 10 to the power minus 19 divided by 5 into 10 to the power 6. So 9 into 158 is equal to 1422 multiplied by 1.6. This is equal to 2275.2 divided by 5. This is equal to 455. Approximately this is equal to 455.04. So I am just taking the approximate value, which is equal to 455 into, now 10 to the power 9 into 10 to the power minus 10. This is equal to 10 to the power minus 10, and this is 10 to the power 6. So this will be equal to minus 16 meters. So this can also be written as, if I multiply this value by 10 and divide by 10, then I will be getting the value as 45.5 into 10 to the power minus 15 meter. Now we know that 10 to the power minus 15 meter is equal to 1 for me. So the distance of the closest approach will be equal to 45.5 for me. So in this question, the most important thing was the utilization of the work energy theorem. So we have used this work energy theorem in order to find the distance of closest approach of this alpha particle. So thank you very much for joining this session. In the next session, I will be continuing with a different topic from the same chapter of atoms. So till then, have a nice day. Bye.